Okay, now we're going to take a look at an application of where we might use these limits. So let's take a look at one of these. Okay, you might recognize this from one of your maybe a physics course or so. It says Ohm's law for electrical circuits is stated V equals Ri, where V is a constant voltage, R is the resistance in ohms, and I is the current in amps. Your firm has been asked to supply the resistors for a circuit in which V will be 10 volts and I is to be within 0.1 or 1/10 amperes of 5, plus or minus, of course. So the question is, in what interval does R have to lie for I to be within 0.1 amps of this target value? And they tell us an initial or I naught value of 5. So I naught equals 5. So I'm going to write down the formula, V equal R over I. All right. Now, the thing is, I'm sorry, that's not the correct formula. V equals Ri. All right. I'm jumping ahead. And we need to get this in terms of the current I, because we are talking about a tolerance level on I. So if I rethink this formula, what would I look like? Well, it would be V divided by R, because I want everything in terms of the amperage here. So let's see here. V equals 10. Okay, what else do I know? I know that I naught equals 5. Okay, and I know that 5 plus and minus 0.1 is our amperage, and so this kind of tells us that our epsilon value is 0.1. All right, there's our epsilon value. So what we're looking for in essence is the interval of acceptance or interval of tolerance for what would be our delta otherwise. Okay, so let's see here. I've got all of that written down. I'm going to now substitute what I know. I'm going to say V over R, which is the current I, minus I naught has to be less than my epsilon, which is 0.1. Okay, and I know that my V, my voltage, is going to be 10 because that was given. What I don't know is my resistance, and that's what I'm solving for here. Okay, and that's one of the primary reasons why I had to write the current in terms of the voltage and the resistance. All right, so there's another inequality, and that results in a compound inequality that looks like this. All right, 0.1 there. All right, looks something like that. All right, we've got that set up. Now we're going to add 5 to both sides. All right, we have something that looks like this, 4.9 less than 10 divided by R less than 5.1. Okay, now what I'm going to do is I'm going to look at each of these independently. Okay, I'm going to look at first this part of the inequality and try to solve for R, all right, in terms of the inequality. All right, so let's see here, 4.9 less than 10 divided by R. I'm going to multiply both sides by R to get rid of that. And then I'm going to divide both sides by 4.9. So divide by 4.9. So my resistance for sure has to be less than 10 divided by 4.9, which is about 2.04. And now I'm going to go back and I'm going to look at the flip side of the inequality. And I'm going to say, okay, 10 divided by R has to be less than 5.1. So I approach it the same way, multiply both sides by R and divide by 5.1. Something like that. And so R has to be then If I'm looking at it this way, r would be greater than 10 divided by 5.1. All right, and so you could read it the other way, r greater than, and then 10 divided by 5.1 is about 2. So if you want to be a little more precise, you could say 1.96, right? So our resistance, okay, because notice what it says, and in what interval does r have to lie? All right, well, r has to be somewhere between 1.96 and 2.04. all right, it has to be somewhere in there. So you might see something like that. All right, 1.96 and 2.04. The other way that they might write it out is if you multiply, you would say 10 over 4.9. all right, 10 over 4.9, and the other one would be 10 over 5.1. However, it's not customary to write them as decimals, so you'd have to clear that by multiplying the top and the bottom by 10. Okay, 10 and 10 and 10 and 10. All right, and that will give you an equivalent fraction. So in this case, 100 over 51, and the other one would be 100 over 49. Okay, so that's another way to express the interval here. All right, so either one of these should be acceptable. Just depends, I guess, where you're keying in your answer. But it's an application of this idea of delta, okay? And we don't know exactly what the resistance is. What we do know is that the resistance has to be somewhere in this range, all right? In that interval of R. All right, so just a little word, an application anyway, on the precise definition of limits and epsilons and deltas and all that good stuff. So as always, if it's helpful, remember to like and subscribe.